Hi students, this is the lesson on transformations and similarity, and we are going to be following along with pages 103 and 104 in your workbook. This is a short lesson, so hopefully you can enjoy a little bit of a break from longer math lessons. So first we need to turn to page 103 and look at the graph that's on the top right hand corner. You're going to see shapes A, B, C, D, and E. And you don't have to worry about the blanks that are on page 103. We're just going to follow along with what's on the video. So what I first want you to do is look at the first rectangle, rectangle A, and let's say this is rectangle A, and think to yourself, how did that rectangle get to be rectangular B or rectangle B? How did it turn into rectangle B? What process did it take to get from here to here? And if you said a slide, you're correct because this one slid down to be here. But then if you look from A, B, and now C is on the left-hand side of the graph, you have C right here, and C is now not only a slide, but it's also something else. It slid and it rotated. So if you said that this one rotated, you're correct. It slid, you can either have it slide this way and it would have rotated. And then how did A turn into D? Well, if you look again, it's another rotation, and it's right in the center of your graph going over the origin. And then we have box E, or rectangle E. It kind of covers the whole box, and that's not drawn perfectly, but so you have A, but now A and E are no longer just a rotation, they are something else. And if you remember back to our dilations, this is a rotation where it flipped and it was standing up and down like this one, and it dilated. So now it's a bigger rectangle up here. So when shapes are rotating and changing in size, they are in size but not in shape. They're going to be similar shapes. So the definition for two figures, or right here, two figures are similar if one can be obtained from the other by a sequence of translations, reflections, rotations, and dilations. So you can go ahead and fill in the word similar on that blank. And then again, just to emphasize, similar figures have the same shape, but they may be different sizes. So these are all examples of similar shapes. They are all the same shape, they are all a rectangle, but they all have different sizes, different lengths, widths, heights, and but they still are similar shapes. Okay, so we can have, this can apply to anything. If you're looking at ovals, you can have an oval that's one size, and you can have an oval that's another size. They're not congruent because they're not the exact same oval, but they're similar because they're the same shape. They're just in different sizes. So all those drawings that you were doing, those are all similar drawings because they're the same shape, they're just different sizes. Okay, so then if we move on to page 104, page 104 focuses on what we talked about here. How did the shapes on page 104 at the top change from one to the other? So if you look at square A on the graph on page 104, you have square A, you can draw it here, and then you have square B, and what did square A do to be turned into square B? So there's a couple things. First, we noticed that it slid. So there was a slide, a translation that occurred. So you would first say there was a translation, and then you would also say that it dilated. It grew, it got bigger. So there was a slide and a dilation. And again, you do not have to fill in these pages on page 104. This is just for your knowledge. And then the next question is, are shapes A and B similar? So are A and B similar? Well, if you go back to our definitions for similar shapes, they are the same shape, but they have different sizes. So these are the same shape, they're just different sizes. And then for letters C and D, or for shape C and D, on the middle of page 104 on the graph, you have a shape that looks like this. I'll draw D first to the best I can. And then C. Okay, so they're asking, what did shape C do to get turned into shape D? So shape C was the original, the pre-image, and then D is the image. So what happened to C to change it to D? Well, we can see that it rotated, first of all, because this point is facing the opposite direction on this new shape, and it also slid, it moved up on the graph, and there was one more. Can you tell what it is? Is this the same shape? Are these the same sizes? If you said no, you're correct, because they dilated. This one became bigger or this one became smaller. Depends on how you look at it. Okay, so then all you need to finish or tell me on these notes, just kind of answer these questions in your head. Is this shape and this shape, are these similar shapes? Yes or no, and why? And is this shape similar with either of these shapes? If they are, why? Why are they similar? Just answer those. Give me a yes or no sentence just kind of on this page saying, yeah, or just circle which two shapes on of these three are similar. And then tell me these shapes are similar because dot dot dot, and tell me why they're similar. Okay, so that is it for this lesson, and then I will see you in class very soon.